The voltage reading of 115 volts at the base of the high-pressure sodium light pole could be a result of induced voltage, sometimes referred to as ghost voltage. This phenomenon can occur when a live wire is in close proximity to another conductor, even if they are not directly connected. The electromagnetic field created by the energized wire can induce a voltage in the nearby conductor. This can cause it to register a false voltage when measured with a voltmeter. When the high-pressure sodium fixture was disconnected and replaced with a 100-watt incandescent lamp, the induced voltage, while registering 115 volts on a meter, may not have been sufficient to supply the current required to overcome the resistance of the lamp filament. As a result, the lamp would not light even though the voltmeter was still indicating 115 volts. The burned-up neutral conductor feeding the pole could have significantly contributed to the induced voltage issue. A neutral wire is intended to provide a low-impedance return path for electrical current back to the source. If the neutral conductor is damaged, deteriorated, or completely disconnected, it can cause voltage imbalances within the electrical system. These imbalances can manifest as elevated voltage readings and increased levels of induced voltage in nearby conductors. The fact that the incandescent lamp illuminated correctly when connected to a different circuit in another location further supports the diagnosis of induced voltage as the primary cause. When connected to a properly functioning circuit with a solid neutral connection, the level of induced voltage present would likely be negligible, thus allowing the lamp to operate normally. To mitigate the effects of induced voltage in electrical systems, there are several recommended practices. Firstly, maintaining adequate physical separation between energized conductors and other conductive materials is important. This increased spacing reduces the strength of the electromagnetic field interaction, minimizing induced voltage. Secondly, ensuring the integrity and proper connection of the neutral conductor throughout the electrical system is vital. A properly functioning neutral provides a stable reference point and minimizes voltage imbalances that can exacerbate induced voltage issues. Thirdly, using shielded cables or conduit can help to contain electromagnetic fields and reduce induced voltage in nearby conductors. Shielding provides a barrier that blocks or redirects electromagnetic radiation, preventing it from inducing voltage in adjacent wires or components. Furthermore, grounding all metal enclosures, conduit, and equipment helps to create an equipotential plane, minimizing voltage differences and reducing the risk of induced voltage. Grounding provides a low-impedance path for fault currents, helping to protect personnel and equipment from electrical hazards. In situations where induced voltage is unavoidable, using appropriately rated surge protection devices can help to protect sensitive electronic equipment from damage. Surge protectors divert excess voltage away from connected devices, preventing them from being damaged by voltage spikes or surges. When troubleshooting electrical problems, it is important to use a combination of voltage, current, and resistance measurements to accurately diagnose the issue. Voltage measurements alone can be misleading, as induced voltage can give false readings. Current measurements can help to identify overloaded circuits or faulty components, while resistance measurements can help to detect open circuits or short circuits. Additionally, it is important to follow proper safety procedures when working with electricity, including wearing appropriate personal protective equipment and de-energizing circuits before working on them. Electricity can be dangerous, and it is important to take all necessary precautions to prevent injury or death. Firstly, always assume that any electrical circuit is energized until it has been properly de-energized and tested. Use a voltage tester to verify that the circuit is not live before touching any wires or components. Secondly, wear appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect yourself from electrical shock and arc flash. Thirdly, never work on electrical circuits while standing in water or on a wet surface, as water is a good conductor of electricity. Fourthly, follow all applicable electrical codes and regulations when installing or repairing electrical wiring and equipment. These codes and regulations are designed to ensure the safety of people and property. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician to do the job for you. Electricity is not something to be taken lightly, and it is important to leave it to the professionals if you are not sure what you are doing. Sixthly, use the right tools for the job. Make sure your tools are insulated and in good working condition. Never use damaged or worn-out tools. Seventhly, be aware of your surroundings. Look for potential hazards such as overhead power lines, exposed wires, and wet surfaces. Eighthly, take your time and work carefully. Rushing can lead to mistakes and accidents. Ninthly, if you are working on a circuit that is connected to other circuits, make sure to label all the wires and components so you can put them back together correctly. Tenthly, if you are not sure how to do something, ask for help. There are many resources available to help you learn about electricity and how to work with it safely. Induced voltage can also be affected by several other factors, including the length of the parallel conductors, the distance between the conductors, the frequency of the voltage, and the impedance of the circuit. The longer the parallel conductors, the greater the induced voltage. This is because the electromagnetic field has more opportunity to interact with the nearby conductor. The closer the conductors are to each other, the greater the induced voltage. This is because the electromagnetic field is stronger closer to the energized conductor. The higher the frequency of the voltage, the greater the induced voltage. This is because the electromagnetic field changes more rapidly at higher frequencies, which induces a larger voltage in the nearby conductor. The lower the impedance of the circuit, the greater the induced voltage. This is because a lower impedance circuit allows more current to flow, which creates a stronger electromagnetic field. In some cases, induced voltage can be high enough to cause problems with sensitive electronic equipment. For example, induced voltage can cause computers to malfunction, data to be corrupted, and communication systems to fail. In these cases, it may be necessary to take steps to reduce the induced voltage. One way to reduce induced voltage is to use shielded cables. Shielded cables have a layer of conductive material that surrounds the wires, which helps to block electromagnetic fields. Another way to reduce induced voltage is to ground the equipment properly. Grounding provides a low impedance path for fault currents, which helps to reduce the voltage on the equipment. Induced voltage can also be a problem in underground cables. Underground cables are often buried close to other cables, which can lead to induced voltage. In these cases, it may be necessary to use special grounding techniques to reduce the induced voltage. In addition to the above, the age and condition of the wiring can also play a role. Older wiring may have deteriorated insulation, which can increase the amount of induced voltage. Similarly, damaged wiring can also increase the amount of induced voltage. It is therefore important to inspect wiring regularly and replace any damaged or deteriorated wiring. When troubleshooting electrical problems, it is important to use a systematic approach. Start by identifying the symptoms of the problem. Then, gather information about the circuit, such as the voltage, current, and resistance. Next, use a multimeter or other test equipment to measure the voltage, current, and resistance in the circuit. Finally, analyze the data and determine the cause of the problem. It is also important to remember that electricity can be dangerous. Always follow proper safety procedures when working with electricity. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical circuits while standing in water or on a wet surface. And always de-energize circuits before working on them. One common misconception is that a voltage reading always indicates a working circuit. This is not always the case, as induced voltage can give false readings. Another common misconception is that grounding is only necessary for safety. Grounding is also important for reducing induced voltage and improving the performance of electrical equipment. Furthermore, it is important to understand the difference between voltage and current. Voltage is the electrical potential difference between 2 points, while current is the flow of electrical charge. A circuit can have voltage without current, but it cannot have current without voltage. Finally, it is important to remember that electrical codes and regulations are designed to ensure the safety of people and property. Always follow all applicable electrical codes and regulations when installing or repairing electrical wiring and equipment. In conclusion, The presence of 115 volts at the base of the light pole without the ability to light a 100-watt bulb is most likely due to induced voltage combined with a compromised neutral connection. Thoroughly inspecting and repairing the neutral and implementing mitigation techniques for induced voltage are essential for resolving the issue. Always prioritize safety when working with electricity.